And we are live. We're going to give just a few moments for folks to join us here. As you come in, please let us know where you're joining us from in the comment section. Hello and welcome to our virtual Lunch and Learn. Today we're talking about smart sensors with IO Link. My name is Rachel Green. I'm the digital communications specialist here at McNaughton-McKay Electric Company. Presenting for us today is JJ Tiara, Global Marketing Manager for the Sensing Group with Rockwell Automation. JJ is joining us from his home office in Massachusetts. Out in the comments section today, ready to answer your questions, is Gerald Clark, Systems Engineer from our Toledo branch. We'll also have a Q&A portion at the end for JJ to answer your questions in more depth. We'll be getting started shortly, but we'd like to allow a few minutes for attendees to join us. As you come in, let us know where you're tuning in from in the comments. As we continue to socially distance, we're happy to be able to host these live sessions here on YouTube, making it possible for you to join us from the comfort and safety of your own homes and offices. You can view recordings of previous Lunch and Learns on our YouTube channel under the Virtual Lunch and Learn playlist. And we'll be continuing this series every Wednesday at noon, so be sure to join us on your lunch break on those days. For anyone just joining us, welcome to our Virtual Lunch and Learn. Smart Sensors with IO Link. Let us know where you're joining from. We'll be looking for questions as you have them in the comments while our presenter JJ Tiara introduces you to smart sensors from Rockwell Automation and how their powerful data can be used across your facility to increase uptime by using preventative and predictive maintenance. Our specialist, Gerald Clark, will do his best to respond in the comments as we go along, and we'll also have a Q&A segment at the end of JJ's presentation to address some of those questions in more depth and to allow some time for any follow-up questions you might have. If you'd like to reach out to us afterwards, or if you have further questions for JJ specifically, you can send us an email at mcmclive@mc-mc.com. Just be sure to let us know which session you attended, and we'll direct your questions to JJ. We'll have that email address on the screen for you at the end as well. Looks like we have quite a few attendees, so I'm going to get started here. JJ, I'll pass it over to you now.
Thank you. Hello, everybody. I'm getting an echo. I'll continue. What we are going to discuss today is smart devices and how they can be used for smart manufacturing. I'm actually going to conduct a demonstration. And the core message takeaway, I would say today, is going to be how Rockwell is in a unique position to provide value for the connected enterprise by bringing device info all the way to a dashboard, device to dashboard. That's the core takeaway for our message. When we look at the environment out there, we see the relationship between OEMs and end users is becoming more of a partnership for production, because the capability to deliver value over the lifetime of a system is becoming more and more important. There is strong push for prescriptive maintenance. Know about the issues before they happen and know what to do about them. Now, if you have diagnostics information coming back, then you can really get to preventive maintenance, predictive maintenance. And once you know that diagnostics information, you know what to do about it and make it prescriptive. Machine builders face the challenge that how to get the performance, best performance out of machine, do different applications, more applications. And also how can I create a differentiation for my equipment versus the other suppliers? I have no easy way to help my customers to prevent problems. And that's what actually the end users are looking for. They're looking for the performance, of course, the sensors or other devices they have, they get the performance out of them. And when the system has a problem, how to find that problem very, very quickly, and how to reduce my downtime, prevent the problems, and reduce the downtime, have maximum uptime. That's what all the challenges which the end users are facing. If you look at overall the business drivers for this, end users wanting to exceed the productivity goals, they want faster time to market, improved asset utilization, risk as well, and get the equipment back up running if there is a failure of a safety device or safety device has tripped in a way, then they want it up and running again quick enough. OEMs are also looking at how do we drive differentiation in our equipment. End users want flexibility, and OEMs have that as a challenge to offer flexibility in the equipment so that a machine can be used to run different products and can be adapted very, very quickly. How do we get the best performance out of that machine? How do I provide aftermarket service and support? A lot of the OEMs are now looking at subscription models where they would be responsible for reducing the downtime at the plant by monitoring the equipment. Now, if they were able to remotely monitor that equipment, that becomes much more effective to be able to provide that service. So they are looking at also their total cost to design, develop, and deliver smart machines. Let me go on to look at Rockwell's vision for smart manufacturing, which we, as all of you know, is the connected enterprise. Smart plants, meaning the information from the real-time information being brought back to the people who are managing it from the plants. And in order to bring in real-time information, you also need smart machines, the equipment to be smart. And for the machines to be smart, you need devices which are on the machine, which might be motor controls and sensors, actuators, all of those to be smart. So that's where it begins. I'm giving you an example here of a smart machine. If we were to bring in real-time data, what's the voltage, what's kilowatt hours, running time, temperature, and I have highlighted margin. Margin is a term used in sensors, although it's applicable to other items as well. I'm showing, for example, a photo sensor, the dust building up on the conveyor. The sensor will fail, and it will lead to production loss, of course, once the sensor stops detecting because of the dust buildup on there. Now, if the maintenance team was advised on this and they take care of that issue before the sensor stops operating, they have avoided a large, big shutdown from occurring. And that's how one can prevent, and big emphasis, I would say, comes in on the preventive part of it by having provided the diagnostics to take care of. Let me take some, and the value of, when we look at the smart devices, the value really increases over the lifetime of the system. I am showing here some value in design, but design value is perhaps a 10% of the whole thing. When you look at how the smart devices, by bringing in the diagnostics info, can help you implement, operate, and maintain the devices, maintain the equipment better, and reducing downtime every year, and that's how it keeps on increasing over the lifetime of the system. Now, you would say in design time, sometimes people say, well, it takes more effort to put in smart devices in there than just the on-off sensors. Well, if a plant is going through the digital transformation and want the plant to be smart, equipment to be smart, in that case, the design time which is spent towards implementing it, I will show how with the Rockwell Automation system and the whole approach, it is faster than other systems to be implemented as smart systems. What makes a device smart? Of course, the first thing is the device information and the diagnostics. But then there are several other things, some enabling technologies being used, what kind of user experience one's going to go through in trying to implement it, and what kind of analytics is available. The best info, of course, is coming from the device itself. It's created at the source. For example, a photo sensor getting dirty, the lens getting dirty, or a pressure sensor telling you that pressure has dropped below a set point. And an inductive sensor, for example, the target has drifted out of range or close to getting out of range. Temperature sensor sending you some information. All that information is coming really from the devices, and the warnings and the alarms are coming from the devices. Now, all sensors, all devices are not created equal. What the information sent by our devices would be different than some of the other suppliers. We have more info perhaps in a lot of the cases. And also within our sensor families, you will see there are some differences as to some sensors. The latest sensors are providing more information than the initial ones which we had introduced. And we continue to improve our portfolio of the smart devices for bringing this info. I'm going to give you here some examples of how a margin is defined and how it works. On the left-hand side, you see the photo sensors. On day one, let's say a reflector is installed at 10 feet from the sensor, margin is 10. What that margin means is that the signal which is received, light required for the sensor is 10 times the minimum required light. So it's 10 times light is being coming back. However, over a period of time, dust builds up and now the margin's reduced to 3. So now its sensor is still operating okay, but it'll stop operating if the margin drops below 1. On the inductive sensors, it's very similar situation. The specified sensing range, you should not use the sensors in the last 20% of the range, so you cut it down. And the same is true for photo sensors also. You never install the sensor and use it at the specified sensing range. You always have a factor there. And here, if the sensor, the target drifts into the last 20% of the range on an inductive sensor, we send a margin alarm, low margin alarm, saying this not getting enough signal back. Now, in our barrel style sensors, we also have a feature that if the target hits the sensor and damages the front end, and now the sensor is no longer being able to detect, it'll send a message saying the sensor has been damaged. That is very interesting. It happens a lot at the plants. And once that happens, you don't even come to know that the front end, the sensor is not working. Sensor just has on, off as 2 states, and one thinks that there is nothing to be detected in front of it. Internal temperature of the sensor. A lot of our sensors we bring back, what is the internal temperature? That enables to review if there are some certain things going wrong on the sensors or in the plant, on the machine. On the right-hand side, I show some of our new sensors, although there are several other, as you know, with the smarts and the IO-Link built into it. Now, I'm showing the diagnostics type of information, margin low, temperature, low pressure, all helping towards preventive and predictive maintenance. I have another comment there, received signal strength, signal level. We, on a lot of our sensors, bring back the actual signal level. For example, the right side sensors, the 42AF and 42EF, we bring back the signal level. That enables you to do a lot more applications and know all the time when there are things going wrong on a sensor. And we have that in the fiber optics amplifiers, which I'm showing here in the screen as well. The next thing comes is enabling technologies. How do we bring in that information and diagnostics back? IO-Link is the enabling technology which we use in our sensors. GuardLink is the linking technology for the safety applications. And then we have the add-on profiles, the Studio 5000 software, which we have, and all this seamless info flow from device to dashboard. That's where I'm going to get it to as we go through this. But all these are the enabling technologies. IO-Link and GuardLink sit beneath the Ethernet IP, which is the main network for everything. What is IO-Link? Well, a lot of you are already familiar with it, but I'll very briefly go through. It's an open standard communication protocol by the IEC standard, and it's not a field bus. It's actually point-to-point communication. When you see the diagram sketch on the right-hand side, you see a sensor and the certain output pins are shown there. If you connect the output pin, pin number 4, or which is a black wire, and that by the standards, that's standardized on everybody's product. It's defined by the IO-Link standard. If you connect that to a standard input module, SIO I show over there, it will give you only the output status being either on or off, as you see the waveform over there. But if you connect it to an IO-Link master, the industry calls it IO-Link master, then the sensor starts sending signals as you see the waveform going over there. And each bit contains certain information. One bit would be for output, another one margin low alarm, another one might be saying there is something in the proximity on a background suppression sensor. Other bits might be there bringing in a lot more information. So that's how the communication takes place. The sensors are forward and backwards compatible. You can take a sensor with IO-Link and you can use it as just, if you connect it to a standard input module, it'll just give you on off as the output. But if you connect it to the other one, the IO-Link master, it'll automatically start communicating all the data. Also, the masters we have designed are forward, backwards compatible, that you can configure the channel where the sensor is connected to be either saying that I'm connected to a IO-Link enabled sensor versus a standard sensor. Another thing you would notice is the cable. Cord sets, connections are staying the same. It's not like the device net where you require special connectors, cables and everything. Here it is, everything staying the same. In Rockwell's strategy, we have kept the prices of the sensors as well the same. There is extra cost. Their extra cost is going into the master per point, and we'll discuss that as I go along. We have two different masters. One is the in-cabinet solution around the point IO 1734 AENTR, which you see here. And this is the plug-in module is 1734-4 IOL. That's our IO-Link master. It has got 4-point capability. Now you can bring in just on-off type of sensors. The symbol, the two arrows symbols you see, that's the IO-Link symbol. The data comes in through that, and the IO-Link master converts it to Ethernet IP. Once on Ethernet IP, you're connected. Here I'm showing it just connected to a controller. Also, the measurement sensor. I'm showing a pressure sensor here, or it could be a distance measurement sensor. Any sensor enabled with IO-Link, which is actually supposed to give you 4 to 20 milliamp or 0 to 10 volts. But here, let's say that sensor has the IO-Link capability in it, then it goes to the same module, 1734-4 IO. You don't need an analog input module. Analog input modules are more expensive than this module, the IO-Link master. So there is upfront cost reduction also. I would also say that OEMs, a lot of the OEMs have already adopted it as its upfront cost reduction. However, the need really is to adopt for diagnostics, for other things. And that's where they may not right away accept it, thinking that that increases the per point cost. I would say that per point cost increases peanuts as compared to the downtime reduction it can bring to a plant. When we look at different plants and different production lines, the numbers which you hear about the downtime cost, a brewery told me that that their downtime cost is $110,000 an hour. A soft drink plant, depending upon what's the production line, that specific production line's output would give you a different number and could also run to about $100,000. Now, there may be the biggest numbers come from the automotive industry, as you know. Ford, every 57 seconds there's a truck rolling off the line, and their number is $1 million an hour loss if the plant stops. And that's the most profitable line up to the point that they have announced that they're going to make only trucks. Similar numbers come from some of the other plants as well, other auto plants as well. But let's say the number is only $10,000 an hour. But is it only in a year you lose only 1 hour? No, you lose minimum of 3.5 days. I was listening to a session on BAM session on high availability systems, and 3.5 days is the minimum number which any plant ends up losing, and a lot of them lose a lot more. At that $10,000, it comes out to be $1 million a year. That's what we are after with smart machines, with the connected enterprise, to reduce that cost. Upfront cost reduction, great. We have the hubs and all that as well. We can do that too. But bigger target is smart sensors used for bringing diagnostics back. On the right-hand side, I show an armor block module on Machine Master. This is an 8-point device with a splitter over there. You see 4 connectors, but you can connect 2 sensors, 2 devices to that. And you bring in power, 24 volts DC. On the top, you see device level ring with 2 connectors for Ethernet IP. Ethernet IP device level ring capability is there. I missed to mention, you also see actuator valve manifold. So you can, on both the sides, you see the in-cabinet as well as the on-machine solution. You can actually drive outputs with the same module. So that module is an input module for on-off sensors. It's an input module for measurement sensors, and also an output module that you can configure that port for an output. And you can drive multiple valves, for example, if that valve bank has IO-Link attachment adapter with it. And currently, all the suppliers, major suppliers, Festo, SMC, Avenix, all of them offer that. And wow, all 3 devices in one. No doubt that IO costs can go down with this by use of different ways. On smaller machines, one of the OEMs, when I was trying to find out what are they using it for, said, well, we use it for everything. One module can do all those things for us on small machines where they have a mix of sensors and actuators. Overall, in the architecture, so the sensors bring in information coming from the sensors through IO-Link, goes to the master. Master converts it to Ethernet IP. Once on Ethernet IP, we are connected to all our devices, controllers, the HMIs, and also all the way, I would say, to mobility devices. So we can bring in all that information from a device all the way to a dashboard. Now, on the right-hand side, I show some of our devices, sensors, encoders, for example, RFID system, and then the code readers, all of them directly on Ethernet IP. You are aware that we announced a code reader about a month ago. It's shipping now. It's Web Connect. It also has Ethernet IP with connection to special add-on profiles for working with Studio 5000. So I would now go into the demonstration to show you features of the diagnostics features of the sensors and all the things which we have capabilities in our system. On the left-hand photo shows my demo setup. Some of you may be familiar with our Mr. Demo setup. That's what I have. I have 4 sensors connected to it. I have the center screen shows what the display looks like, but I'm going to bring that display onto my laptop screen. And on the right-hand side, I'm showing that the attachment is a L1 Compact Logics controller in that demo setup. On the back of it, I have a 1734 AENTR, the point IO base, and I have 2 plugged-in modules in there, the IO-Link masters. But I have only 4 sensors connected, so only one of those modules is getting used. I've just lose two items there. One of them is the armor block master, uh, and the second one is an IO-Link hub. IO-Link hub, you see 8 ports there. You can actually connect with splitters 16 devices to it. For example, 16 push buttons, 16 limit switches, or 16 sensors where you don't necessarily need all the smarts and diagnostics coming back. You could bring those back. The hub converts those signals to IO-Link. From that connector, you connect it to an IO-Link master, and now you are with just one point, one channel of a master, you are able to monitor 16 devices. I must say, there is no diagnostics coming back. It is only giving you on-off output of a sensor. So this is not a smart device. However, this helps in the upfront cost reduction, IO reduction. It does reduce that. And just keep in mind that this is not where all the diagnostics is coming from. For diagnostics to be brought back for the overall downtime reduction, you need to have the devices coming out into the master itself. However, this device does have a place, and we have a model which also has the capability to drive with a second connector on the hub to be able to drive outputs with 2 amp capability in there. On the right-hand side, I show that on the back of my demo, there is another unit sitting. That unit is FactoryTalk Analytics for devices. It's an appliance which Rockwell supplies. You can see I have the 24 volts power connected to it, and I have an Ethernet cable. That Ethernet cable is going into my system setup, the demo setup. And that is monitoring everything, what's going on. And I'm going to show later, and we'll actually demonstrate how it is getting the signals from it. Let me go on to I'm going to get out of the PowerPoint and go on to my demo screen. You see that I have several blocks here, but I'm going to go through each one, kind of showing what capabilities are built in. And I'm going to start with the diagnostics part of it. I have 4 sensors connected. Communication is showing up as good to 4 of those. I don't have anything on the 5th one, so that's why it's showing failed. I am going to take the right side sensor, which all of you are familiar with, and I'm going to put my hand in front of it. And the output is on now, and it's also sending a signal over there to the demo, to my HMI Panel View Plus, saying output is on and margin is good. I'm looking at, please look at the second row from the bottom. If I can create a dusty condition by making the signal level go down by just moving my hand out. As you know, diffuse sensors will get less signal from a farther away point. Here it is. At this point now, the sensor's output is still working. It's working, but it sent a message saying margin is low. That is the preventive maintenance time. Somebody can go in and clean the sensor, and that's how. Now, we put in also a feature which we say something is in the nearby and about to trip the sensor output on, near object. You have a background suppression sensor, and you say, it shouldn't be seeing something in the back. Why is the sensor detecting part? So it is a caution signal coming back also, which helps towards maintenance and making sure that the things are proceeding okay. That is the key thing. And if I were to do it on an inductive sensor, it'll be the same way. If it moves into the last 20% of its range, it'll send a low margin alarm signal. What happens then if in case a cable breaks or a cable gets shorted someplace? Today, because the output is just on off on a standard sensor, you don't come to know. You think everything is working okay. Only when things start going wrong on the machine, you start producing bad product, or things fall off the conveyors, that's when you come to know. Here in this case, I'm going to disconnect this sensor, and right away the person gets the message that sensor has failed or connection has failed. Communication is not good. So it is great in finding issues. I was at a distribution center. Very large number of sensors were to be installed over there. And when they showed that there were 6 floors of conveyors all over the place, hundreds of sensors already installed. Uh, to them, this feature, connection break, and the margin alarm is such key information. They have to make deliveries, either the shipments, either the same day or the next day. And the only way they come to know when there is a problem is when the things start falling off the conveyors. And then they have difficulty trying to find where that sensor is. And I'll show you a feature which they loved it, how they can locate where the issue is as I go along. Uh, I will also show you additional capability. I also had mentioned that signal level. By the way, this is actually sending a signal level back as a digital signal. And we make use of that for several different applications, which currently out there, it's already getting used. Here's a laser measurement sensor I have. I'm aiming it at the wall. The center row on the screen you see, it's measuring the distance. It's saying it's 1200 millimeters, 1250. Now, you can set this up as background suppression. It's also bringing signal level. But I have set it up. There is one output on this on off. Triggered one, you see that it's measuring at 340 or so. It's giving an output on. But I can set multiple windows. Here, I'm going to go to 600 millimeters, and you will see there it is. It's saying another output on. So you can set up virtual outputs, multiple virtual outputs, windows, to be able to do more applications. Well, first part was the diagnostics for preventive maintenance, which is where the big savings come in for all sensors. Even the ultrasonic sensors we just introduced about 2 weeks ago have signal quality coming back to tell you if there is not enough signal coming back. So that is great towards preventing downtime with that. But let's say a failure has occurred on a sensor, and now you want to go ahead and fix it, and you find which sensor. Second shift guy, third shift guy may not know in the plant which sensor is giving the problem. We have a field in the setup when the sensors are being set up that you can name the sensor, associate application specific name, for example. Hey, this is my in-feed sensor, this is my out-feed sensor, and or this is my jam detect sensor. For example, I have a sensor here named 1, 2, 3, 4, 5, 6. I can change that to write. This is a 32 character field. I'm just going to write a few in there. And you can write that as the name for the sensor. And that becomes, that's the idea, is to help the guy find it very, very quickly. Once he knows what that sensor is, he says, okay, I'm going to go to the machine or to the plant, the conveyors, find where that is and get the catalog number. Well, he goes, looks at the sensor and finds out that the catalog number is not legible anymore. In that case, now it's an issue that, he has to dig through records and all that. We have the bill of material right in front of him. He doesn't even have to go out to the floor to look at it. And I'm going to show the face plates at the same time. We have created to make it easier for OEMs and end users so that they don't have to create their own. This is a faceplate for the 4-point IO-Link master. If I go in there, see 4 channels. And if I go to any one of those channels, it'll come in and tell what's the complete catalog number of the sensor and what's the application specific name for it. So the guy didn't even have to go out there to get that information. It's great, helps them. And this other one you see, faceplate, is for one of the sensors, color mark sensor, to set up this. It helps in setting up the sensor. So now that he has that information, now his next task is to get that sensor from stockroom and go install it. Now, what was the sensing range set up? Whether it was a potentiometer on a right side sensor or a push button on a 42JT sensor, how does he now set up that sensor? Was it the output light operate or dark operate? How is he going to find all that data, old data? Here, we have the automatic device configuration feature in there, which you know that we have it in our drives as well. The reading you see, 900, this is for the 42JT sensor. I'm not sure whether this will come out okay on that. Actually, you can see the LED going on and off as I move my hand. It's set up for about 3 inches sensing range, and that is the 900 internal threshold setting for that. Now, when the sensor ships from the factory, it has a range of 32 inches to 90% reflective paper. Here, somebody set it up for that. If this sensor, I won't be able to do the demo properly in person, it comes out more better, but the idea here is you remove this sensor, he puts the new sensor on, the 9,900 reading is stored in the PLC. So is the rest of the configuration, light operate, was the push button locked or unlocked, everything's stored in there, and he connects it right away, instantaneously, everything gets downloaded into the new sensor, and the sensor starts operating the way it should. It is a very powerful feature, and it is in our systems, all the data is stored in the PLC. You can also store a lot more things in the PLC. For example, for a color mark sensor or you need to set up two sensing ranges on a sensor, you can set up different profiles, different recipes, and then preset them so that when the line is changing, you don't have to go setting the sensors up again, teaching the sensors or adjusting them. You already have the profiles. You just from the HMI select the profile you want to run, and you're able to very quickly get the line changed to produce a different product. We have created also descriptive controller tag, contextualized controller tags, so that an OEM does not have to do it. And so they are already standardized. Output is triggered, margin low alarm, proximity alarm, all that is coming through, and they don't have to be preparing. Those are all differentiators from what you see as other suppliers who are also supplying this type of equipment. So these are some of the things, and I'll show you some of the other features. For example, the right side sensor. What's the temperature inside the sensor? 49 degrees. What is the maximum since inception? 61. So it is bringing in the information and it's storing that data inside the sensor. Even if you remove the sensor from there to some other place, the historic data will stay with the sensor. How many hours the sensor has been in operation for since inception and also since last power off. All that data is available, helps in troubleshooting when things go wrong. I mentioned the distribution center where they have sensors installed every 30 inches with zone controls. And once by the way, reflector misalignment will also send the same, low margin signal. So here we have a feature, we call it location indication feature. I have this sensor here. I'm going to say locate this sensor, and the sensor is flashing. The LEDs start flashing. So it's a lot easier to find now on the machine or on the line. And the sensor is still operational. You can see that it's still detecting. So everything is preventive maintenance. He hasn't lost any production. Those are great features. I will also mention the signal level, which I had, some of the applications which have been done with the signal level. Tissue paper plant, where when we pull out the tissue paper out of a box, the next one is ready to come out because there are two layers over there. And they need to detect that is getting packaged properly. Part of it is single layer, another part is double layer. They mount this through beam sensors like this. The maximum signal is received when there is no tissue present. But if there is a single layer of tissue present, it cuts down the signal by about 20–30%. If there is when there are two layers present, it cuts it down by another 20–30%. Set the thresholds in the PLC, and now they are able to detect actually three conditions, three states. Very good enhanced functionality right there. They were able to get rid of some expensive equipment. And I know of a couple of plants, a couple of different companies which are using it this way now. I was also at an automotive plant where I had been informed that they had an issue. One of the vehicles got out of the plant with the front seats as leather seat and the rear seat as cloth seats. Quite an embarrassing situation for the company. We offered the same solution, right side sensor. It gets a much bigger signal, diffuse sensor from leather versus cloth. You know that diffuse sensor, the light can get all the way. I'm wearing a gray vest today, but if I was wearing black vest and all that, it'll absorb all the light and nothing would come back. So they are they are now implementing a method where very inexpensively can mount the right side sensors to check whether the seats leather or cloth seats. And they have all kinds of other error proofing and cameras and all that, but somehow that error got through and they don't want that to happen again. It's quite embarrassing for them. Uh, that was my demonstration on the different features. I'm going to move back to my PowerPoint. And when we look at safety system, again, if something, one of the devices trips, devices are wired in series, and safety switches, safety devices. If one of them, here I'm showing several doors, for example. So which one has tripped? Loss of production time in trying to find the fault. Uh, with the smart safety architecture, we have the GuardLink where with the relay, the GuardLink relay, which can monitor, I'm showing one string, but actually there can be two strings capability on that relay. With smart taps connected to each one of these safety devices, it brings back on that single cable the information on where the issue is, which one has tripped. And the attached gray item you see is the unit which converts the signals to Ethernet IP. So again, same architecture, which I showed for the sensors. GuardLink brings the information through the GuardLink relay to Ethernet IP. And once on Ethernet IP, you can be connected all the way to a dashboard, to even to the mobility devices and the controllers and everything, and to the world. That's how somebody can remotely monitor it. I mentioned the remotely monitoring feature. Somebody would say, well, the end users do not want that, want to allow that because of security reasons, very valid reasons, of course, security reasons, no doubt. But when there is a problem and somebody is losing $100,000 an hour and somebody to wait for somebody to fly in to take care of the issue, they can selectively give permission to remotely troubleshoot if that can be done that way. So there is that benefit, and they can get around the security issue by just giving the permission selectively for the plants where they do not want to allow all the time to be equipment to be monitored by the suppliers, OEMs or SIs. On the right-hand side, there are devices which we have which are directly on Ethernet IP. So the base network is Ethernet IP, of course. Well, let's look at the relays, the traditional overload relays. Well, the relay helps protect the motor, so the motor doesn't get damaged. But production is down at that time. It's purely a reactive maintenance operation. On the other hand, the E300 smart overload relay, it monitors the current and enables the current. If the increase in the motor current, it gives that as feedback, and somebody can take care of it before the actually motor shuts down or the production is lost. Again, same concept, bringing in diagnostics early on. As a matter of fact, 75% of the motor failures can be prevented if you had a lot of data coming back about the motor's performance. And we have the same architecture for those devices as well to bring the information onto Ethernet IP. And from Ethernet IP, you can now connect it to the world as well as that enables the connected enterprise, all this. Coming to the next part, which we feel is crucial towards making the devices smart, is what kind of user experience in trying to implement all this. Rockwell is the only supplier which offers, well, controllers, software, the IO-Link masters, and the IO-Link devices, the sensors. There may be other suppliers who have sensors and masters but don't have the controllers, and vice versa. Uh, Having all the equipment, we have the ability to do premier integration with Studio 5000, creating add-on profiles, controller tag names already created. And I'm going to show view faceplates also, FactoryTalk view faceplates. All that being there, these are all our differentiators for us. And we provide the whole solution, device discovery in the latest software firmware, which we have in the IO-Link masters, automatically will discover the devices which are connected. So one doesn't have to spend time on trying to enter those items in there. We already went through the automatic device configuration. Timestamps. This is a feature in our Armor Block IO-Link master. It will record what time certain events occurred. Connection broke, margin went low, somebody changed the settings on a sensor. All that, of course, can be done remotely, with the two-way communication going through. But it timestamps and tells what time it occurred. If a plant is losing production, they can right away find out where the issue began, or they have started producing bad product. They can see where that started and set that production aside. Add-on profiles. This is showing, just as an example, add-on profile on one of the sensors and showing what kind of items are connected. And you're working in the environment where our people are already used to the Studio 5000. The add-on profiles, we have actually created device-specific screens also, and which will give you graphically show you the information to make it easier. FactoryTalk View faceplates. So we have them for initially with Panel View Plus, but now for the View 5000, as well as FactoryTalk View Machine Edition, Site Edition. Now, I would say that we introduced about 6 sensors within the last 5-6 months, and those are under development, and they will be pretty soon coming out. Portfolio, our emphasis is on expanding the portfolio and all these items along with it. Designed for analytics. That is so crucial. And when you look at this part, and I'm going to again demonstrate it, I think you're familiar with FactoryTalk Analytics for devices. I mentioned that I have that unit sitting on the back over there. In this slide, it's shown as in the center over there, analytics appliance. This unit can monitor up to, when it's connected into an Ethernet network, it'll monitor up to 100 Ethernet nodes. It'll monitor and bring in information from that as to whatever operation is going on, is any maintenance required. I am told that, at the brewery, one of the breweries, when it was installed, it right away picked up some battery low on some equipment, battery was low. It picked up something that the programming should have been done in full duplex, was done in half duplex. So the Rockwell has already set up completely that unit to be able to work without any programming or anything else being required. It's already done. And I'm going to go into the demo part of that instead of continuing here. And the idea is to bring it all the way to a dashboard, which you see on the top part of there. Bottom is sensors and other devices bringing in the information, connecting through the appliance, FactoryTalk Analytics for devices. And then at the top, you see the display, the dashboards. Let me, again, get out of my presentation and go live on this. This is the screen. I'm connected now to what's coming from the FactoryTalk Analytics for devices. It's already bringing in, telling I have a Panel View Plus 7, I have a 17 L1 controller, I have a power supply, and I have these 1734 point IO base, and then I have the 1734 IOL mod, or IO-Link master. I'm going to go on to that one. Wow, this is actually telling me that the signal sensor is about to fail due to insufficient light. Right now, my sensor is lying on the floor, looking at the carpet, not enough signal coming back. Let me pick that sensor up. I'm going to bring it to in my hand. But in the meantime, I'm also going to disconnect one of the sensors here. I'm going to disconnect one of the sensors. And I am going to, by the way, that low margin condition went away, but I'm going to create that low margin condition once again. It's saying channel 1, device is either not connected or not operational. So it has sent the fault message on that sensor, which I had disconnected. Now it has sent the message saying channel 3, the 42 EF sensor is about to fail due to insufficient light being reflected. Isn't that amazing? It's coming directly to the dashboard. It's management by exception. It's telling you only about the device which needs attention. And it tells you where that device is connected. It's saying it's connected to the port 1. I have 2 masters over there, but it's telling me that it's connected to the number 1. And channel 1 has one fault and channel 3 has another one. There is an action deck on this as well, in this and those same messages are going over to that action deck as well. And when an issue is resolved, it'll also send a message saying the issue has been resolved. For example, the 42 EF, right now it's showing that there it is. It came in as a message that the issue has been resolved. How good is that? For people managing the plants, it's sending them information by exception, telling such and such equipment needs attention. So please keep that in mind. That's our device to dashboard message and ability, and it's available now. Everything is available now. You're seeing it as a demo, full demo. I will extend it one more step. How many of you are familiar with Factory Talk Team 1, which we have a free app for mobility devices? I have it on my phone. I cannot right away, get connected through the system, but in a live demo, I usually bring in the messages on my phone, and I'm going to go on to the Factory Talk Team 1, and there's an action deck here on there, and the same messages are coming to my phone as well. So the name Team 1, a supervisor in a plant, a manager, can set up a team of people who are taking care of the maintenance part of it and making sure the plant is running and at capacity and all that. They will get a message. He has a team of people, let's say, and he sets up a team. Each one of them gets a message, or he gets a message and then assigns it to someone. And once the issue is resolved, he also gets a message saying the issue has been resolved. That is our, going to get out of this and go back to my PowerPoint. This is that same screen, the Factory Talk Team 1, which I was just showing it live on my phone, but here is on a slide. I'll mention a tire plant application. I've been mentioning some of the examples where it has been used. A tire plant. The tires come off the curing press, and they are hot at that time. They go on a conveyor just to cool down in long conveyors. And if the two tires hit each other, both tires get ruined. This plant told me that they lose 10 tires per day as a minimum. And that is a huge loss. Their internal calculations were that by installing the smart sensors, they can save $350,000. They installed the sensors. I was at the plant about a month after the installation, and they are using the low margin alarm indication. So the sensor sent, and they've created their own faceplate, actually, the whole huge display there. And they love the location indicator feature. They have implemented that as well. Actually, they mount the reflector at about 6 feet, while the sensor has a range of 30 feet, 33 feet, actually, 10 meters. And so at 6 feet, it's sending a very good signal level back. However, as the dust builds up on it, it'll start going down. But because they have such a huge margin, good margin to begin with, it takes longer time versus, let's say, if they used a sensor which had a shorter range, more than 6 feet, but still a shorter range than that 30 feet sensor. In some cases, one of the corners areas where the distance was more, they are using a through beam sensor. So getting a large signal back. They even set up through IO-Link, they can set up the threshold when the margin alarm is going to come on. We have an internal setting, but they can override that and they can get the alarm earlier than, let's say, what we have set up for the margin. And they did that. Their indications to me are that they will be looking at implementing this across their other plants as well, and not only in one area, but in other areas also. Let's look at, we initially did talk about that, IO-Link enabled sensors, analog output sensors can reduce costs. For example, here I'm showing how the analog point IO module cost is, and it requires shielded wiring when you're using 4 to 20 milliamp or 0 to 10 volts. But here, with the IO-Link master, with IO-Link enabled sensor, you don't need shielded wiring, because the signals which I showed are very robust signals, 0 to 24 volt signals. And also the IO-Link master, the point IO one is lower cost. Paper plant, this paper plant had air blown at every sensor to keep it clean, and compressed air is very expensive. They were implementing, in this case, roll diameter detection load when the rolls need to be changed, using a laser measurement sensor, which sends the signal quality information also. They can automate, actually, they have automated the process when the compressed air is going to be thrown at the sensor to keep clean the sensor. So again, operational cost savings and also upfront cost savings, because the analog sensor doesn't need to be no shielded wiring, one other thing, no scaling required to set up the sensor. It automatically sends you distance in millimeters, or a pressure sensor or a temperature, directly sending you the information, no need for any scaling for setting it up. This is the example I mentioned about the plant where multiple, very large number of sensors were installed for bringing in diagnostics. I mentioned this example already as well, where the tissue boxes packaging, how you can do more applications with that. Simplified valve control. On the right-hand side, you see a photograph where, wiring going to several valves on a valve bank, and it's a big mess. If the IO-Link attachment was there and you were driving it with the IO-Link, you could drive multiple valves just with one 4-conductor cable coming into the valve bank. Initially, they installed it with the point IO base master 1734, but they have now changed over to the armor block master. One needs to consider how much is the current taken out of the master, because the current for the valves is coming from the master itself. But huge cost savings they have achieved by doing it this way. A tortilla stacker machine, another example where they have these flour makes the sensors dirty pretty quickly, and they get a signal, margin low alarm and location indicator. So the differential value, coming back to the same slide which I had initially put up, it increases really with the lifetime of the system. It keeps going up, as you can see. And I've explained how in design time it is better as compared to some other suppliers, because we have done the premium integration and makes it easier to implement the smart solution. And if I were to take a look at the tire application example, which I mentioned that they are using it, I mean, the cost savings they said they would achieve is $350,000 in a year. but they put in perhaps $15,000-$20,000 in the best return on investment one can get by, so it can reduce scrap or downtime or different benefits. Device to dashboard. That's the message. It's available now. It's there, and that's what we would like you to be looking at, taking in, and helping your customers overall with our approach to smart devices, smart machines, and smart plants. These are the basics, sit beneath the connected enterprise. Well, thank you very much. I'll answer questions. We can open it up for questions. And also the email address is there for sending questions at a later time as well.
Thank you, JJ. We do not have any live questions at this time, but as JJ mentioned, we'd like to reiterate that you can reach out to us even after this live stream has ended at the ncmclive@nc-mc.com email address. We'd love to give just a few seconds here to see if any questions do come through, if you have any follow-up inquiries here for JJ. Thank you again to JJ for his presentation and to Gerald for being our resource in the comment section today. And thank you to all of our live viewers for your time. We hope this session was informative and engaging for you. For those who were registered to attend this session in person and received the live stream invitation via email, we would appreciate your feedback on a brief survey, but that will be coming your way shortly. And remember to subscribe to the McNaughton-McKay YouTube channel for more industry content. Okay. Thank you again, JJ. We look forward to seeing you all live again soon. Have a great day.